Types of graphs. Types of graphs are based on the degree and the leading coefficient. There's 4 types of graphs separated by the degree that they have, either odd or even, and the leading coefficient, either positive or negative. Looking at the first 2 graphs, if they are even means it has an even degree, like 2, 4, 6, or 8. If it's an even degree, both sides either point up or both sides point down. If it's a positive leading coefficient, a positive number, both sides will point up. If it's a negative leading coefficient or negative number, both sides will point down. And likewise for a odd function. Odd again means a odd degree, like 3, 5, 7, or 9. If it's a odd function, it either starts at the bottom left and goes to the top right, or it starts at the top left and goes to the bottom right. If it's a positive coefficient, again a positive number in front of the degree, it'll start at the bottom left and go to the top right. If it's a negative coefficient, it'll start at the top left and go down to the bottom right. All the curves in the middle of the graph are based upon the rest of the function. Title of the first section today is Graphing. Determine zeros. And max/min. In this section we'll graph polynomials, we'll determine the zeros, and we'll find either the max and or the mins. First function we'll look at, f of x equals x cubed minus 2x plus 6. Looking at this function, we can decide the shape of the graph based on the previous section. This is an odd graph. X cubed would be an odd graph, and the coefficient in front is positive, so we'll have odd and positive. So looking back at the tables we just did, this graph will start at the bottom left and curve up to the top right. To get the precise graph, we can make a t-table, x and y. We can use any numbers for x and y, but the numbers we'll use for this section will start at -2 and go up to +2 using 5 values. So we'll have -2, -1, 0, 1, and 2. Plugging these numbers in to the expression, we'll find f of x, or the y value, and then we can graph the 5 points on the next y-axis. Starting with -2, if you plug a -2 into the expression, -2 cubed would be -8. -2 times -2 would be +4, and adding 6 to that, we'll have -8 plus 4, which is a -4, plus 6 would be a +2. So our first value would be 2. Repeating for the next 4 values, -1 cubed would be -1. -1 times -2 would be +2, and plus 6. -1 plus 2 would be 1, plus 6 would be 7. Plugging a 0 in, the x's will be zeros, we'll add 6 to that, so 0 will be 6. Plugging a 1 in, 1 cubed would be 1, -2 times 1 would be -2, and plus 6. 1 minus 2 would be -1, plus 6 would be 5. And last number we'll plug in 2. 2 cubed would be 8, minus 2 times 2 would be 4, plus 6. 8 minus 4 would be 4, plus 6 would be 10. Taking these 5 values now, we can graph them on a xy axis to get the graph for the function. The first point that we have is -2 and +2. Second point is -1 and 7. And 0, 6, 1, 5, and 210. So graphing the 5 points, we'll connect them in order from left to right that we graphed. And we'll get a shape that looks similar to the graph that we originally thought it would be, which is starting at the bottom left and going to the top right. To finish this graph, we want to find these zeros. The top right of the graph goes off to infinity, so there'll be no zeros on the right hand side, but the left side of the graph will continue to drop down, so we'll have some zero on the negative x-axis. To find that zero, we can plug another number in by continuing the t-table. Since we left off at -2, we can plug in -3 to see if that's where the zero would be. If you plug a -3 in to the original equation, -3 cubed would be -27. -2 times -3 would be +6 and +6. -27 plus 6 would be -21, and -21 plus 6 would be -15. So -3, if we drop the graph down 15 spots, we'll have another point that we can graph and connect that to our line. Since we know this is an odd positive graph again, the graph will continue to drop to the left-hand side. To find the zeros for this graph, looking at the x-axis, the zero will cross between -2 and -3. So our zeros, since we don't have an exact value, we can put between -3 and -2. And the last part for this section, max or min. Max or min will be relative max or relative min. What that means is we'll ignore all the negative values that go down to -infinity, and we'll also ignore all the positive values that go up to +infinity, and just look at the middle of the graph with the curves. The relative max will be the top of the curve, and the relative min will be the bottom of the curve. So for the max for this graph, we'll have x equals, and the top of the curve in the middle of the graph occurred at -1, so x equals -1. For the relative min, again ignoring the negative values, but back at the middle of the graph, the bottom of the curve was at +1, so the relative min is at x equals +1. So we'll have our graph. We have 1 0, which is somewhere between -3 and -2, and we have one relative max and one relative min. Title of the last section today is More Graphing. Determine zeros. And max/min. In this section, we'll continue to graph polynomials. We'll determine the zeros for those polynomials, and we'll find any relative max or mins. First question, and only question for the section, f of x equals -x cubed minus 4x squared. Before you graph functions, it's a good idea to figure out the shape of the graph. This graph is an odd function, since the degree or highest exponent is odd, and it's also negative since the coefficient is negative. If we have an odd negative function, looking back at the examples we did at the beginning of these sections, odd negative graphs would look something like this. Starting at the top left, have some curves in the middle, and then go down to the bottom right. To graph functions again, we can use a t-table, xy t-table. And you can use any numbers, but the numbers we'll use for the section will be -2, -1, 0, 1, and 2. Starting with these points, we'll get an idea of what the graph will look like, and then we can add more points as needed to get the correct shape. Plugging a -2 in, we'll have negative, and a -2 cubed would be -8. -8 with a negative outside would become a +8. So -2 plugging into the first term would be +8. -2 squared would be 4. 4 times a -4 would be -16. So our first y value would be -8. Continuing on, plugging a -1 in. -1 cubed would be -1. With a negative outside though, that would become a +1. And -1 squared would be +1. Times a -4 would be 1 minus 4, or -3. Plugging a 0 in, both x's would be 0, so the y value would be 0. Plugging a 1 in, 1 cubed would be 1, the negative makes it a -1, and 1 squared is 1 times a -4, which will give us -5. And 2 cubed is 8. With the negative outside, we'll have -8. And 2 squared is 4. 4 times a -4 is -16. -8 minus 16 would be -24. So taking the 5 y values that we have, we can graph those and add more as needed depending on the shape of the graph. Graphing from here. The first point we have is -2, -8. Second point is -1, -3. 0, 0, 1, -5. And 2, -24. The 5 points again, we can connect in order from left to right. And that'll be the graph for this function so far. Keep in mind though, we want the graph to finally look like the original shape, a odd negative, which goes down to the right, which is fine. But the left-hand side for odd negative graphs points up to the left, which means this graph on the left-hand side will have to curve back up, and we'll have a 0 somewhere on the negative x-axis. To find those points, we'll just continue using points, plugging them into the equation to find out where the graph turns around at. So our t-table we can continue. Since we did -2 on the left-hand side, we can plug in a -3 and see where -3 would have the graph. Plugging a -3 in, -3 cubed would be -27. With that negative outside, would make it +27. And -3 squared would be 9. 9 times a -4 would be negative or minus 36. So 27 minus 36 would be -9. Graphing that point, it's actually one spot below our last point, so the graph continues to go down, but it starts to turn around since the distance is getting smaller and smaller each time the graph goes. So again, we can continue picking points until the graph curves back up, and we'll find the 0 for the graph. Plugging the next point in, -4. We'll have -4 cubed, which would be -64. The negative outside makes it a +64. And -4 to the second power would be 16. 16 times a -4 would be -64. So we'll have 64 minus 64, which will be 0. Graphing this point, -4, 0. We'll have the 0 for the graph, and we'll also have the graph turn back up and go up to the top left, which will match the shape of the graph that we should have. So this will be the graph for the function. And last part, we can determine the zeros. Zeros again are where it crosses the x-axis. In this case we have two zeros and they both point at integers. We have -4 and 0, so the two zeros would be -4 and also 0. To find the max and min, or relative max and relative min, again ignore the ends of the graph where it goes off to positive and negative infinity, and only look at the curves in the middle for the relative max and relative min. For the max in the middle of the graph, the top of the curve will be at x equals 0. So the relative max will be x equals 0. And for the min, looking again at the middle of the graph, the bottom of the curve, which was at -3, we'll have a relative min at x equals -3. And that'll be the graph, the zeros, and the max and min for the equation.